Hello everyone, and welcome to this little math tutorial video here where we're going to be looking at finding the roots of rational numbers, which is also on IXL L2. So if you're having a little trouble with that, hopefully this will help. And of course you can always rewind and pause the video as you need. So let's look at this one. So we're going to have square root of 4/25. Okay, so this one's actually very easy. Basically, if I'm doing the square root, I can understand that that's the same as doing it to the 1/2 power. Or, I mean, you should already know what your perfect squares are in this one, so you could write it this way, but you don't have to. So it'd be 4 to the 1/2 over 25 to the 1/2. But this step really isn't that necessary. But the square root of 4 is 2, and the square root of 25 is 5. So my answer would be 2/5 on that one. So if we look at another example. Stylus, it wouldn't work. Okay, so this one we have the cube root of 125 over 27. Okay, so on this one, the thing is, some calculators do have a cube root button, but others do not. So if you're using a basic calculator at home, then there's a pretty simple way that you can do this problem. So basically, we're doing the cube root, so we're going to do to the 1/3 power. So we're going to have 125 to the 1/3. And I wanted that to look like an exponent, but it does not. So yeah, be sure when you're doing this that your bases are larger. So 125 to the 1/3 over 27 to the 1/3. Of course, if I know my perfect cubes, I know that 125 and 27 are both perfect cubes. Okay, yeah, this is not being the nicest to me. All right, so that's going to be 5 over 3. If I do them both to the 1/3. Now you may be wondering, if I have a basic calculator, how do I put that into the calculator? Well, I would do it like this. I'd do 125 and then my exponent button, which most of the time looks like that, but on some calculators it may be different. And then I will put, since I'm doing a fractional exponent, I would put 1 divided by 3. And I'm putting it in parentheses because otherwise, depending on the calculator, it may not follow the order of operations. It may not consider that as an exponent. It may do 125 to the 1st power and then divide all of that by 3, which will not be the answer that you want. So that is how you would do that. Then you do the same for 27 to the 1/3. Okay, so let's look at another example. So on this one, we have, let's do another cube root. So let's take the cube root of negative 343 over 1,000. Okay, so on this one, you actually can take the cube root of a negative, because I can do a negative times a negative times a negative, which will be a negative. You can't do the square root of a negative, though, and have a real solution. And that's how we learned about imaginary numbers earlier. But on this one, we can do this, and so basically if I were to type this in the calculator, I would do it as negative 343 to the 1/3 power over 1,000 to the 1/3 power. And that's going to give me negative 7, because 343 actually is a perfect cube, and so is 1,000. So it would be negative 7 over 10. Okay. And Alright, let's do another one here. So let's say that we have the fourth root of 10 over 81. Or 16 over 81, my bad. Okay, so we have the fourth root of 16 over 81. So this one is going to be the same way. So I'm going to do 16, but since I'm doing the fourth root, I'm going to do it to the 1/4 power. And then on the bottom, I have 81 to the 1/4 power. So that's going to equal the fourth root of 16, because 16 is a perfect fourth, ends up being 2. And the fourth root of 81, which is also a perfect fourth, that one will be 3. So I have 2 over 3. And one more example for this. So let's do this. Let's say that I have, let's say that we have the square root of 0.0064. Well, you can actually just type this in correctly, or directly, I mean. So I could just type that directly in, or I could type it to the 1/2 power because I'm doing square root. So I could type it to the 1/2 power. But basically, I'm thinking what number times itself twice is 0.0064, and that would end up being 0.08. Because I know 64 is a perfect square, so 8 times 8 is 64. We just have a decimal here, so it's kind of a funky looking decimal, but that's really all there is to that. So if you have any questions, feel free to email or message me that way, and I wish you good luck. You got this.